Our final example 3, we have a paper airplane that's thrown from the top of a 36-foot high building with an initial velocity of 30 feet per second. So we first need to write the equation here. So we have the 36 feet high building. So this is going to be our h naught, our initial height. We have our initial velocity. So this is v naught. And the fact that we're talking about feet, then that means that we know our acceleration is going to be that negative 32 feet per second squared. So in our formula, it's 1/2 times the acceleration, t squared, plus v naught t plus h naught. So our formula, h of t, we get from doing 1/2 times the acceleration. So that's going to be 1/2 times negative 32. So we'll get negative 16 t squared plus v naught t, so that's plus 30t, plus our h naught, which is 36. What is the maximum height of the paper airplane? So think about what it is that we're being asked here. For the maximum height, remember that this is the y coordinate of your vertex. Now, to get the y coordinate, we're unfortunately going to have to first find the x coordinate. So even though it doesn't ask for it, we still need to figure out when is the time that this actually occurs. So we need to do negative b over 2a. So in this case, that's negative 30 divided by 2 times negative 16. So negative 30 divided by negative 32. If you type that in your calculator, you're going to get 0.9375 seconds. So we want to now figure out what is that maximum height. So if I want to figure out the height, I take h and I evaluate it at 0.9375. So negative 16 times 0.9375 squared plus 30 times 0.9375 plus 36. And you type that in your calculator and you follow order of operations and you get about, and we can just round to the nearest tenth, that's fine. It's going to be about 50.1 and our label here would be feet. So to actually answer this question, this is your maximum height. That's what they're looking for here. Part C, what is the height of the airplane after 1 second? You're going to evaluate h of 1. So doing negative 16 times 1 squared plus 30 times 1 plus 36. And following order of operations there, you're going to get 50 feet. Okay, so 50 feet off the ground after 1 second. How many seconds will it take for the airplane to hit the ground? Well, that means anytime we're looking for it to hit the ground, this is where we set it equal to 0, and then we solve. So 0 equals negative 16t squared plus 30t plus 36. If we use the quadratic formula, we're going to do negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. So simplifying this a little bit further, we get negative 30 plus or minus, your discriminant in this case is 3,204. So there's a little check to make sure that you're on the right path. And for your time, you're going to get 2 different answers. You get negative 0.83 and you also get 2.71. Negative time isn't going to make sense here because obviously you don't talk about negative time in the real world. So we would just have 2.71 seconds. Okay, one more problem. At what time will the airplane be at 25 feet? So again, I'm solving for time and I have a height given to me. So this height, this is what I want to set the equation equal to. So we're going to do 25 equals the rest of our equation, negative 16t squared plus 30t plus 36. So I still want to solve this quadratic. And if I'm going to solve it by quadratic formula, I have to get it set equal to 0 before I can move on. So I first have to take that 25 away from both sides. So we get 0 equals negative 16t squared plus 30t, and then 36 minus 25, that's going to be plus 11. So your A value is negative 16, your B is 30, and your C is 11 when we plug it into the quadratic formula. So T, your time, is equal to negative B plus or minus the square root of B squared minus 4 times A times C again, which is now 11, all divided by 2 times that A value. So negative 30 plus or minus your discriminant is going to be 1,604, just so you can check how you're doing there. And when you type this in and you follow order of operations, you're going to get two different answers. You're going to get negative 0.31 and positive 2.19. And just like before, the negative time wasn't going to make sense, so 2.19 seconds does make sense here. So the last part of this problem is asking that you basically take all the information that you found and graph it. So think about these different points that we have here. What is the maximum height of the paper airplane? Well, first we found the time. So at time 0.9375, we get a height of 50.1. There is a point on your graph right there. What is the height of the airplane after 1 second? So at 1 second, your height is 50 feet. There's another point that would be on your graph. How many seconds will it take for the paper airplane to hit the ground? Remember, this is your x-intercept. So this is your x value, so 2.71, and the height is 0. There's another point on our graph. In fact, I might start with this one. So I know that my x-axis needs to go out to at least, I would say, 3. So my x-axis is down here. This is time. I'm going to have it go up by 1. So 1, 2, 3, 4. So 2.71, here's half, 2.5. So here's 2.75. So 2.71, I'm going to say, is about there. So there's my x-axis. This is when that paper airplane hits the ground. Something else that we know, the initial height of that airplane was 36 feet, but the maximum height is 50.1 feet. So we need to give room on our height over here to go up to a little over 50. So I could go up by 10, 20, 30, 40, 50. And we said our our y-intercept, our initial height is 36. So I would be starting there. We had a point at 150, so I'm going to plot that. 150 is about there. And that's going to be really close to where we said our maximum height. This is our vertex right here. So the vertex is just before where this point is at 1 second. The vertex, it occurs at 0.9375 seconds and a height of 50.1. So it's just barely a little bit taller. So 0.9375, here's 0.5, 0.75, 0.9375 is going to be really close, and it's just a tiny bit higher up than that other point was. Okay, and let's see, is there any other stuff? We included all of this. The other point here is we have a time of 2.19 seconds and a height of 25 feet. So 25 feet, 2.19 seconds, I can see 2.19 is probably about here, and up to 25, you probably have another point about there. And it makes sense. You should have a parabola, right? Here's our vertex, so there shouldn't be anything higher than that point. And then it comes back down all the way over here to our x-intercept. Not perfect, but we at least have every other point that we found included on our graph.